Hello students, this is KD sir speaking to you. In today's video, I am going to discuss electrostatics. So in this electrostatics, I am going to discuss 20 most important concepts. 20 most important concepts that is required in to study the electrostatics chapter, and most advanced topics that I am going to discuss, and apart from that some discussion questions also will be there. So I have divided this discussion into two videos. In these two videos I will discuss first 10 important topics, or you can call it 10 important questions in the first video, and in the next video I will discuss with you another 10 important topics. So another thing is that every student asks me, sir, which book I will follow and all these things. So apart from that, see, there is a lot of books that you can get in the market, but mostly that you should follow the NCERT book, right? So in the NCERT book, you will go, not only you will study the chapter, in the chapter you will get it actually 50% of the syllabus, and in the exercise you will get the 25% of the syllabus, and in the worked out examples you will get the 25% of the syllabus. So if you do the entire book, including the exercise, the examples, the chapter, you will get the 100% of the syllabus. And apart from that, you should do exemplar also, exemplar of the NCERT. So exemplar may just you will get it all the good sums also, collections, and don't do all the extreme. Some of the exemplar sums are very extreme hard. Those sums will never come right now. So let's start. Okay. This is the first question. In this first question, you see there is a charge Q kept at this point A, whose position vector is R0, and there is a point P whose position vector is R. The value of the position vector of R0, this R0 value is given to you, that is 2i plus 3j, and the position vector of P, that is R, is given to you as 8i minus 5j. So what we are going to find it out, I have to going to find it out the electric field at this point P due to this charge Q in the vector form. So for that, the formula is E is equal to 1 by 4 pi epsilon naught Q divided by this distance square. That this distance is your vector RAP, and that is RAP, magnitude of it, and whole square. Okay. Now, but you see that this quantity is entirely a magnitude. It has no vector. So to drive this electric field along this direction, what I have to do, I have to multiply one unit vector along this direction RAP. This unit vector will do nothing but drive this full vector, this electric field, along this direction. So this gives you the direction. This is the magnitude of this vector, this electric field. So now the question is, how will I get the vector RAP? So here you see, according to the triangle law, you can see that this vector plus this vector is equal to this vector, that is R0 plus RAP is equal to the vector R. Therefore the vector RAP is equal to vector R minus R0, right? And R is equal to 2i plus 3j minus R0 is equal to 8i minus 5j. That is equals to, I made a mistake, R minus R0. So 1 minute. This is R is equal to your 8i minus 5j minus 2i plus 3j. That is 8i minus 2i is equal to actually your 6i minus 5j minus 3j is equal to your 8j. So this is a vector, that is RAP. And the unit vector, you know that the unit vector, that RAP unit vector will be what? Will be the vector R AP divided by the magnitude of RAP. Now what is the question, that RAP magnitude is how much? The magnitude of RAP, I can write it over here, RAP, you can see it, that is equals to root over d square plus d square, that is 6 square plus 8 square, that is equals to root over 100, and that is equals to 10. So hence, so let's come back to our problem, that is 1 by 4 pi epsilon naught. You know the value of it, 9 into 10 to the power 9. I am not giving the value of the q, it will make you some more complicated, so let us keep this q as a q. And our AP magnitude is already, I found it out, that is 10 square. That means let us keep this is as keep it as 1 divided by 10 square. And RAP is equal to, you know that the vector RAP, that is equals to 6i minus 8j. 6i minus 8j, and the magnitude of it is equal to 10. Now you see this is 9 into 10 to the power 9, 10 square, 6i minus 8j, and this is 10. So here you see this is 2, this is 1, 2 plus 1 is how much? 3, and here it is 9, so it will be q 9 into 10 to the power 6, that is 9 minus 3, because this 12 power into 6i minus 8j. Okay, so this is our electric field value, and this is whatever it is. Next question I am going to. Let there are two charges, each of charge q. There are two charges, each of charge q, and the mass of the two charges is given m. The mass of this charge is also m, and mass of this charge is also m. This is our second sum, let me tell you. And these two charges are hung from the same point with the help of this thread length L. Okay, and due to this has a charge q and this has a charge q, same charge, they repel each other. And when they repel each other, they make an angle with the vertical. This charge makes an angle theta with the vertical, and this charge makes an angle theta with the vertical. So the question was asked, that find the rate of loss of charge if their velocity of approach varies as v is equal to a by root x, where a is equal to constant. So what happens actually, you know, by any reason, because the surrounding is your air, moist air or any kind of air, this charge is they are losing some charges, some amount of charges at a certain rate. That is, think it dq by dt, they are losing the charges outside. Now due to this losing charge, the repulsion between these two charges is decreasing, and they are coming closer to each other. So what is that velocity of approach is given to you as v is equal to a by root over x. And what was asked in this question, they asked at what rate the charge will be emitted from this charge. That one I have to find it out. So what should I do? First, let me see. Here we have the weight of the ball is your mg. This charge is mg, and there is force of repulsion between this charge and this charge is F. And let there be a tension T, and let this T has two components. Let us make this angle is theta. So when this T is resolved into two parts, this is your T sine theta, and this is your t cos theta. Now we can say that we are resolving the force on one of the charges, that is q, that is t sine theta is equal to your F, and t cos theta is equal to your mg. So what is F? The F is actually 1 by 4 pi epsilon naught q into q, that is q square, divided by the distance square, that is x square, and mg is this one. Now if I combine these two equations, you will get it t sine theta divided by t cos theta is equal to 1 by 4 pi epsilon naught into q square divided by x square divided by mg. This is why we can say this is your tan theta. From here I can say that tan theta is equal to, when this t and t get cancelled out, tan theta is equal to q square divided by 4 pi epsilon naught mg into x square. So up to this much is okay. Now you see tan theta means what here? Tan theta means your opposite by base, but here opposite is x by 2, fine. But this height, if you have to calculate with the help of L, it will become root over L square plus x by 2 whole square. It will become very cumbersome, and this is why, and theta is here also very small. So this is why we have to take here, consider here this kind of sums. You have to, in this kind of sums you have to consider this tan theta is approximately equal to sine theta, so that it becomes easier. Easier not, or not only easier, it is solvable only. That is tan theta is sine theta. So this is why I can write now, in place of sine theta we can write that opposite by hypotenuse, that is opposite is your x by 2 divided by hypotenuse is your L. That means in place of tan theta we will write approximately it is sine theta, because when theta is very small, sine theta is approximately tan theta, remember it. And theta is, the value of theta is around, should be less than 10 degree. Theta small means the value of theta should be less than 10 degree. So it will be your, in place of sine tan theta we can write this as x by 2 by L is equal to q square by 4 pi epsilon naught mg x square. Now we can go here we can write this as x cube, this x can go over here, x cube divided by 2L is equal to q square by 4 pi epsilon naught mg into x square. Sorry, x not x square, it will be x square is cancelled. Here x square already I sent to you, here x cube. So from here we can say it is q square. Let us make segregate q square. Q square equals to, you are getting 4, here it is 2 and this 2 get cancelled. So it will be q square equals to x cube 2 pi epsilon naught mg into x cube divided by L. Here is our next sum. You can see a tiny spherical oil drop carrying a net charge Q is balanced by an electric field E. When E is switched off, the drop is observed to fall with a terminal velocity Vt if the viscosity of the air is eta and density of the oil is rho oil, find the charge Q. So you can see this is our charge plate this is a positive charge plate and this is our negative charge plate. Let us keep this charge, negative charge Q, over here, balanced. This is a negative charge because this is the charge of electron. This oil is balanced. That means there is a force along this direction is mg, and there is, due to this, there is an electric field E, but it is a negative charge. We haven't said it, but you have to take it this as negative charge. This is negative charge Q. The force due to the electric field will be upward on this, and it will be EQ. That means when the electric field is there, the EQ equals to weight of the oil drop. So that means I can say that mg is equal to EQ, where m is the mass of the sphere and g is gravitational acceleration. So what is the m will be, mass of the oil drop will be equals to 4/3 pi r cube, that is the volume of the oil drop, into density of the oil into G is equal to your EQ. So that means from here, if I segregate this RQ at this side, I am doing it because I have to keep this R cube. First I have to find it out, this R cube is equal to what? R cube I am getting it as 3EQ divided by 4 pi rho G, rho oil into G. I am writing rho oil as rho naught, this. That means R basically is equal to, you can call this as the 3EQ divided by 4 pi epsilon naught, 4 pi rho naught into G into to the power 1/3 of it. Okay. Now what was the next step? It is the first step. First step gone. That means it was balanced with the help of, that means it is not moving, that means it is balanced. That means the downward force weight is balanced by the electric field force upward. That means these two forces are equal, and I have made it this. From here I have got the radius of the oil drop in terms of the electric field and the charge and the density and the G. Next step, what they said, this electric field is switched off. That means there is no electric field anymore. So if this electric field is switched off and this oil drop starts moving down, that time it will be acted upon by what kind of force? There can be possible two force. When a liquid drop is going down, there can be a force of buoyancy is there, and there can be a force of viscosity is there upward. But here the buoyancy is negligible due to this air, and the oil drop is very small, so negligible. So only I am thinking about the viscous force is acting on it. So viscous force will acting on it will be equals to, again it will be equals to your mg weight of the body downwards should be equal to 6 pi eta r. This is the viscous force acting on it. Now we can get this m. Once again, let us put this m, weight m is equal to, you know that it is equals to 4/3 pi r cube into density of the oil into G is equal to 6 pi eta r, and the velocity, that is the last part I haven't written, that is weighting. Now 1 r and this r get cancelled, this is squared, and you can see this 2 is here and this 2 is cancelled out 3. That means the terminal velocity Vt is equal to, I am getting 2 pi, this pi also get cancelled out. So if I keep this Vt over here and rest of the things I am bringing it over here, I will be having it 2r square into rho naught into G divided by 9 into eta. And the rest thing is very easy, that is this r, just have to replace this over here and nothing more. That means it will become equals to 2 rho naught G by 9 eta, and this thing if I place it in place of r, I will get it 3 eq divided by 4 pi epsilon naught, 4 pi rho naught, sorry, not epsilon naught, into G to the power 2 by 3. But that's all. This is the terminal velocity. If the values are given, then you can easily put the values and you get your answer. So that's all for this sum. This is our next sum. See, there is a ring, elastic ring is kept, which is given a charge Q, and a charge Q0 is kept at the center. What is our job? Is to find the electric, due to this electric force between this Q0 and the charge in the ring Q, you have to find the tension in the ring. There is a tension in the ring outward. So what tension is it is, that we have to find it out. Now for that, what we will do, we will take a small element over here as dx. This is our small element in it, and this is here. The angle subtended by it is our d theta, and let us drop a perpendicular over here. This angle, now the tension will be acting on this small element dx. It will be like this. One will be this side like this, and there will be small, this side will be t like this. Now if I draw a tangent at exactly at this position, it will be like this. This will be your angle t, and this tangent at this position will be this. This is a very small element. So if this is your d theta, this will be your d theta by 2. This small thing will be your d theta by 2. Now if this d theta by 2, this angle will be 90 minus d theta by 2, hence this angle will be your d theta by 2. Hence this angle also will be your d theta by 2. So this tension can have two components. One component is along this direction, another component is along this direction. So along this direction it will be t cos d theta by 2, and towards this direction it will be t cos d theta by 2. So t cos d theta by 2 and t cos d theta by 2 cancel each other, but another component of this t is along this direction, that will be t sin d theta by 2, and another component of this is along also this direction. This will be your t sin d theta by 2. So both of them are having 2t sin d theta by 2. this is inward, and there will be a charge Q naught over here, and this small element has a charge whatever it is that I am calculating it. That small element charge and this Q naught will repel each other. That means there is an external force outward, and this 2t sin d theta by 2 is inward. That means this force and this repulsive force will balance each other. So balance each other means actually 2t sin d theta by 2 will be equals to the force of attraction between this element and this charge. That means that we will apply Coulomb's law, that is Q naught into what is the charge distribution. If I distribute this charge throughout this circumference, it will be equals to Q by 2 pi r and into this small element dx. Dx is the length of this. That means this is the charge of the small element dx. For the small element dx, the charge is this much, and this is the Q naught discharge. There is a repulsion between this charge and this charge, and this is balanced by this force. So, according to Coulomb's law, this is the charge Q1, this is Q2 divided by 4 pi epsilon naught into distance square. That is, it is r square. Fine. So, you can see this here, sin d theta by 2. In sin d theta by 2, theta is very very small. So theta is very very small means the sin will get omitted. So it will become 2t d theta by 2 is equal to, there will be q naught divided by 4 pi epsilon naught, and 4 pi epsilon naught, it is better to write this pi and this pi, make it pi square, and this 2 and this 4 makes it 8. Better to write here 8 pi square epsilon naught. This r and r square make it r cube, and Q is already here, Q naught already here. In place of dx, we can write it as r d theta, because we know dx is equal to r d theta. This we can write it. So this 2 and this 2 get cancelled out, whereas this theta will be cancelled out, and this r and this r will get cancelled out to a square. So hence T will be equals to Q naught divided by 8 pi square epsilon naught r, and hence this is an r square, and this is our answer. If I have anything missed, you can check it out. T Q naught 8 pi square epsilon naught r square. Where is that square? So this is a very important sum, because this sum can be given in a different way. So if you know the basic how to find the tension like this situation, you can do many other sums also. This is how to handle tension in a ring due to center force and subcenter force. There will be tension can be created. So this sum is very important. Okay. Another sum, interesting sum that came in this last West Bengal joint entries is electrostatics, and I am very interested about that sum. It is given that a conductor is there, a conducting sphere is there, and in this conducting sphere there is a hollow is there, and there is another hollow cavity. This one cavity is there is a charge QA over there, and there is a charge QB over here. Now this is a conductor, remember it, not this is a conductor. Now the question is that what is the force of attraction or repulsion between these two charges? The answer to this is 0. The answer, because there is no electric force between these two charges. Because if I think this Q will, suppose this is a positive charge, positive Q here. So it will attract some negative charge over here and corresponding positive charge over here. That you can call it as sigma A. Here also is there is net charge. There is a sigma B over around it, and there will be a negative here, sigma A over here. But one thing you must know, that electric field inside this cavity, due to this, the electric field due to QB in the cavity, where QA is there, is 0. That means this charge cannot apply any electric field on this charge, and neither, because it is inside this cavity, the electric field inside the cavity inside this cavity is 0 due to any external charge. So that means this charge is not affected by the electric field of this, neither this charge is affected by the electric field of this. So that means these two charges do not apply any kind of force of attraction or repulsion between them. There can be a net charge of plus, there can be a net charge of QA plus QB on the surface of it if we want it. That's all to discuss this. This is our next question. We have a charge Q over here, and the question was asked that what is the total flux that is going through this ABCD surface, which is a square of side A, and this charge is kept at a distance A by 2, perpendicular from the center of this square. From here it is kept. This is perpendicular. As you can see, it is in the 3-dimension diagram. Now, most of the students say, sir, you told us the flux is equal to the E into the area. So, and what they do, they take this charge Q and they find out what is the electric field at this position. That means it is, that is the electric field at this position will be equals to 4 pi epsilon naught Q divided by the distance square, that is A by 2 whole square, and into the area will be your A square. But no, that is not the answer. This is not the answer. Why is not the answer? This electric field that I am finding it out is not everywhere. This electric field is this one. The electric field at this point is this one. This exactly at this distance A by 2. But what I asked you the total flux that should come out through this entire area. So in this case, what we have to do? We have to do something apart from this. We have to apply Gauss's theorem, because we can distribute the electric field of this through this square at the different positions. How will you do this distribution? Let us see it. What I will do it, I will place this, I will make a cube. Not here. Let us do this cube. This. Let us make this cube like this. You can see it. This is our Q of the side A. And where I have kept the charge? I have kept the charge over here at this distance, at a distance A by 2. That means what I did, I make a box entirely, I enclose this charge with the help of a cuboid. Cube basically, not cuboid, cube of side A. That means according to the, now I can say according to the Gauss's theorem, the entire flux that is coming out of this enclosed area, this enclosed box is equal to Q by epsilon naught, and that is the total flux coming out of this box, and this Q is kept symmetrically inside this box. That means the flux that is coming out from this space, from this space, from this space, this space, this space, this space is same. So this is why I can do it as, if you think that the area is of this face is your A, this space is your A, this space is your A. Now I can say that the electric field into 6 times A, that is the total flux that can come out. When electric field into area, that is equal to the flux that is coming out. So flux through this it is coming out will be, I can now distribute it as E into A, that is the flux that is through the face A, B, C, D, you can think it, will be equals to Q by 6 epsilon naught. This is the answer. And because I have distributed, nothing I have done, I have just distributed the flux through this phase, this phase, this phase, this phase symmetrically. And this is our answer for this case. Now like this sums, I have another set of sums like this. I am doing it next in the next sum. Our next sum is this. Suppose you have the same, suppose you have a cube like this, and the charge is kept on this face A, B, C, D, center of this face, that is charge Q is kept on this center of this face. Our question is that, now again my question is that this charge is not touching the rest of the 5 faces, 1, 2, 3, 4, 5. The 4 faces it is not touching. Through those 5 faces, how much flux that will come out? So again what you have to do? You do nothing, you have to enclose this Q charge symmetrically from all the side. So for that, what should I do? I have the least way is that to enclose this charge, I have to take this, like this I can enclose it symmetrically in this case. I have not to take 8 cubes as I have taken. Now you see that this is symmetrically enclosed. This side 5 faces and this side 5 faces. In the middle, this thing. So in total faces is how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 faces are there. You can see it has 10 faces. You can take it 10A. And total flux that is coming out will be equals to Q by epsilon naught. And how much I want to take it? I have to take it 1, 2, 3, 4, 5. 5 faces is through which the flux has to come out. That I have to calculate. So 5 faces, you keep it 5 faces, the E into 5A will be equals to Q by 2 epsilon naught. That's all for this sum. Our next question is that I have kept the charge Q here, and this is our box. In one of the edge, center of the edge I have kept it, and the question is that what is the electric flux that is coming out of the rest of the faces which the Q is not touching. It is touching this space and through this space, through this space and this space the flux will come 0 because it is touching it. But the rest of the faces 1, 2, 3, 4 which it is not touching, in total through those 4 faces how much flux it will come out. So for that again what I have to do as previous, I will enclose this charge Q from all the side symmetrically. You can see how I do that. I can extend this box like this. So you can see it here. So the charge Q is over here, or this charge Q is over here. I have symmetrically enclosed it with the 4 boxes. See, 1, 2, 3, 4 boxes. That means in total how much faces we have here. This face area, if I take it as A, same way the other face is A, that means here you will have 1, 2, 3, 4, 5, 6, 7, 8 faces, and here we will have this face. I have 4 faces, and that face also I have 4 faces. So here 8 faces, and here 4 faces, and that back side is 4 faces. In total I have here, it will be equals to 16 such areas, 16 such areas will be there. You can see it, 1 like this, you can count it, 1, 2, 3, 4, 5, 6, 7, 8, and this face has, the front face has 1, 2, 3, 4, and the back face has 1, 2, 3, 4, like this 16, and total flux that is coming out, you know, it is equal to Q by epsilon naught. So our question is that through these 4 faces, how much flux that is coming out due to this charge. So it will be equals to E into 4A will be here, and the rest 4 will be going here, that is 4 epsilon naught. So that means the flux that is coming out here will be, so these 4 faces will be, because 4 area, this is symmetrically that is coming out, and that's that, this is the answer, Q by 4 epsilon naught. Here is 3 sums are there. 3 sums means same sum, 3 different ways these are being given. There is a finite length of linear charge density. There is a finite length of linear charge density, and there is some points. See, this finite charge density is of length how much? I have written it as √3L minus L, and I have kept a point over here, not exact here it is ending this linear charge density. I have kept it away from it by amount of L, and this side it is L. This is a point P where I want to find the electric field due to this linear charge density. Same way here also you can see this linear charge density is over here, and at a distance L at this point P I want to find the electric field. This side it's kept in such a way that the perpendicular dropped divide this base into one as L by L √3, another as L by √3. Another is kept over here. You can see that this is our point P, and this side it is √3L. Now before I do this sum, I have to explain you some formula, new formula for this, because you know for a infinite linear charge density, suppose from infinite to minus infinite to plus infinite linear charge density, if I keep a point here at a distance P, I know that due to that, by the help of the Gauss's theorem in our regular classes, our school for the regular classes, we have already proved with the help of the Gauss's theorem at this point P, by taking a cylinder and all these things, that electric field will be equals to Q by, this charge density is lambda divided by 2 pi epsilon naught and this x, and that's all, you know this. But in this case, this is not an infinite one, this is a finite one, you see, from here to here. And how do I mark it? With the help of the angle theta. So before I am doing these sums, I have to give you 2 formulas for it. So that one I am giving you, and the formula's derivation is Right now it is not required. I will give it in my coming videos. I will give the derivation of those formulas that I am giving it right now. Please write it down. So one formula is that, suppose you have a linear charge density like this, please note it down, and you have a point P over here like this. Okay, now at this point P, the electric field will be two directions. One will be Ex, another will be your Ey, remember it. Another will be your Ey. So what is the value of Ex? See, this is your, make it as theta 2 and this is your theta 1, you make it. From this side, where this side you see, this side it is Ex, this side it is theta 1. The side that is Ex, that one's below is theta 2, please remember it. So Ex will be equals to, first of all I forgot to tell you that each one of them has a charge density of, linear charge density of lambda coulomb per meter. And it has also a charge density of lambda coulomb per meter, and this is also has a charge density of lambda coulomb per meter. Now what will be the Ex over here? It will be equals to k lambda by A. Please remember it as K only. What is K? K is equal to, 1 by 4 pi epsilon naught. That is the value. So no need of writing this thing bar. Just you have not to write this thing every time. So just write K lambda by A, and it will be equals to cos theta 2. Just, and this is cos theta 1. This is 100% correct. I am just telling you this is cos theta 2 is this side and Ex is this side. That one is theta 2 and theta 1 is this side. Which side Ex is not there directed. Please remember it because the minus is here. So it is very important to remember which side, which angle you will take it as theta 2, the first one or the next one, because the side you have that Ex, that side it has theta 2, the which side you are not directing, that one is theta 1. But for the Ey, you have not to worry about it because it is just, both of them is plus. You can see that it is equals to sine theta 1 plus sine theta 2. You can see it. Okay. So these two formulas, please write it down or take the screenshot of this page, this part. So we can start this sum using these formulas. We will do these sums. This first sum, let us do with the first, start with the first sum. You can see here, this is actually, it is supposed to be in the middle. Then I can say this side it is cos, this side it is theta 1, this is theta 2. But here I see, here our theta 1 is this one, fine. This is our theta 1 and theta 2 is the same side it is has become, but actually theta 2 we have taken in the other side, remember it. So in this case theta 2 we have to consider it as a minus theta 2, but this theta 1 is a positive theta 1. So in this case first let us find out what is theta 1, because in this case theta 1, that this is what I have taken the sides in such a way that you will get a good answer for the theta 1 and theta 2, so that you can do it. So I have taken the base as, you can think, if I think this as the base AB, so you can, that is you can take it tan theta 1 will be equals to this plus this, mane root 3, mane this is opposite and this is base, that is equals to root 3 L minus L plus L divided by L, opposite by base, because this is our theta 1. So here it is getting cancelled out and L get cancelled out, and this is root 3 L minus L. So theta 1 you are getting it as 60 degree. Same way you can do the theta 1 tan theta 2 is equal to, you will get it opposite by base, that is L by L, and that is equals to, you will get theta 2 as L and L get cancelled 1, and that is equal to 45 degree. So that means your theta 2 is 45 degree. Now what will be your EX over here? This side it will be your EX, and this side it will be your EY. So to get the EX, K lambda by A is here L, perpendicular distance, into cos theta 1. First is our cos theta 2, which direction that EX is there, that side it is your EX, that means theta 2 will be there. Cos minus theta 2 is our minus 45 degree. But there is no problem because cos minus it absorbs as the minus, so no problem. So minus into cos, this is your 60 degree, that means cos 60 degree is our yes. So it will become K lambda by L into cos 45 is 1 by root 2 minus cos 60 degree is our half. So whatever the answer, this will give the answer for this one's EX part. Now for this one's EY part, it will be your again K lambda by L into sine theta 2, sine theta 1 first, that is sine of theta 1 means our, how much it is, 60 degree, plus sine of this theta 2 we have to take it as minus, that is minus 45 degree. So it will be your K lambda by L, cos 60 degree is root 3 by 2 minus 1 by root 2. That's your answer for this case. In the next sum, this is our EX and EY. If I have to find it out, the resultant of these two electric fields, then you just use E equals to root over EX square plus EY square after finding it out. And thus last you have to put the case value is 1 by 4 pi epsilon naught. This is our first sum, that is here. Our next sum is this one. This one I am erasing it. If you have, you can take a screenshot of it. So next I am going to the next sum. Is here, you can see this is our theta 2, this is our theta 1, and this is our theta 2. So here you can see this is opposite by hypotenuse, that means you can see tan theta 1 will be equals to your opposite by hypotenuse, that means L root 3 by L. So L get cancelled. So you'll get theta 1 as 60 degree. Fine. Next is here L by root 3, that is tan theta 2 will be equals to L divided by root 3 divided by opposite by base, that is L. L get cancelled out, it will be 1 by root 3, and theta 2 will be our, basically it will be 30 degree. So again in this case EX, if I think it this one, then our theta 2 is this, and this is our EY. Okay, fine. So it will be EX will be K lambda by A into cos theta 2. For this will be your theta 2, cos theta 2. Cos theta 2 is how much? Cos of 30 degree minus cos of how much it is? 60 degree. This you calculate just. You will get your answer. A means here it is A naught. It is here written L, so L you take it. But that's all for this one. And for this one, you can see it. I have taken to the end of the things, last end. In this case, this angle that you are going to get it, this is 0, this is 0, cos theta 2 is 0. Basically here no angle is there, only theta 1 here existing. This you can think it as theta 1. So in this case, you can see this is your root 3l. So that means cos here tan theta 1, or you can say it as tan theta equal to will be equals to root 3l divided by l. L will get cancelled. That means theta is 60 degree. The other end, that is there is, because this is the edge of this length 3l, so this side it will be 0. That means if I think it as ex, it is like this, and ey is like this in this case. So ex will be taken as k lambda by l into cos theta 2 will be a 0, cos 0, minus, because this side there is no angle, this is because these are the edge, it is standing over here. So this you will take it as theta 1, that is theta 1, or theta you can take it as it is, that will be cos 60 degree. And you know that k lambda by l, cos 0 is 1 minus cos 60 degree is your half, and you calculate ex, that is 1 minus half is half, and that whatever it is. Next is your ey will be equals to k lambda by a, same way l, it will be your sine theta 1. Theta 1 means this theta basically it will be 60 degree plus sine 0. So sine 0 is 0, sine 60 will be equals to your k lambda by l into root 3 by 2. So that's all for these two sums. Now in all the cases, if you want to find the resultant electric field, you have to do it is equal to root over ex square plus ey square. That's all. This is our next problem. Our problem is here. The next problem, you can take it. This is an infinite linear charge density, but the difference is here from the standard one. This side it is infinite, it is going infinite, but I will take a point over here which is at a distance r at the edge. You can take it as L also, at R also, anything you like. At this point P, I have to find the electric field at this point P. So as you know, there is two angles are there. One is your theta 2, another is your, you can call this as the theta 1. So from this you can check it that there is, since this has the edge, that is theta 2, there is no theta 2. So theta 2 tends to 0 basically. Theta 2 is equal to 0. And theta 1 tends to what? Theta 1, as it is going away, this angle is going on increasing, that means theta 1 tends to 90 degree. Hence Ex is equal to our formula Ex. You remember that Ex is this side, whereas Ey is our this side. So it will be k lambda by a into cos, this side it is theta 2, that means cos 0 minus cos 90 degree, and you know cos 0 is 1, cos 90 is 0, so it will be only k lambda by a. Next is our Ey. Ey is, you know that the formula is k lambda by a into sine theta 1 plus sine theta 2, and our theta 1 is here tends to 90 degree, cos this is our theta 1. Theta 1 tends to 90 degree, that means it will be k lambda by a into a means our, actually I forgot to write, this is as not a, it will stay as r. This will also become your r. This is also your r, and this is also your r, because we are taking the distance as r. It will be your sine 0, sine theta 1 is sine 0 not sine theta 1 tends to 90 degree, so it will be 90 plus sine 0. So it will be also k lambda by r. And if you want to find the electric field at this resultant electric field E, that means E will be equals to root over, that is k lambda by r whole square plus k lambda by r whole square, that is basically will be k lambda by r into root 2. It's okay, this is the sum. That's all for today's video. In short, we will come up with the next part of the second part of the video, in which I will discuss the rest of the 10 more topics, 10 more concepts I can say, which we will discuss about the electrostatics. So students, please stay tuned, and thanks for watching today's video.